Here is the abstract of this course. And this course examines the mathematical foundation of machine learning. And the first part presented by Cuturi sensei, statistical learning theory, whose aim is to learn from numerical and continuous data. And the second part, presented by me, computational learning theory, whose aim is to learn from discrete data, such as formal languages and the formula of first-order logic. And both parts consist of fundamental theories and the method to apply them in practical settings. Okay? And the brief contents of the first part is just like this. And this part is taught by Cuturi sensei from April 16th to May 28th for 7 weeks. And at first, the first part is static learning on static learning theory. And the first week, introduction to regression and classification theory and algorithms. And then he provides a probabilistic framework of classification and static learning theory. This means includes that Cherubnensky's theory, and pack learning, and capacity measures. Okay? And the third item is brief introduction to advanced topics, just like support vector machines, kernel methods, and sparse regression. Okay? And the second part, the latter half, is taught by me from June 4th to July 23rd. And this is on computational learning theory. Okay? At first, I give some preliminaries on formal language theory and computational formalization of learning. And then I introduce learning finite state automata and context-free grammar from positive and negative data. And the third subject is to show the difficulty of the learning from positive-only data. And then I show the learning patterns or monomials from positive-only data and show the hierarchy of learnability. And the last content is learning from finite state auto with queries. Okay? We will explain later more precisely. And this is very important point for you. And for the graduate school student on master course, students in master course are graded by examinations provided by both during the course and after the course. Okay? The examinations may be given in the form of a take-home report, in Japanese so-called report. And the students are expected to correctly understand the concept on statistical and computational machine learning. Okay. This is a requirement by us. And today, I don't have any print out, but such a course material and the text will be provided by the classes system after student registration is completed. Maybe it is very late, the second week of May. So before that, please visit our homepage. Our homepage address is here. Then you'll find today's slides and next week's slides. Is that okay? Any questions, in particular on credit, marks, reports, examinations? Okay, you agree with me. Okay. Then, Cuturi sensei introduce his part.
Okay, so So I will just present the half course that I will be giving in the next weeks. So the first part, as Yamamoto Sensei was mentioning, is about statistical machine learning. So let me just give you a very brief introduction to some of the topics that we will address and what this course will be about for you. The first introduction is probably about big data and what data can do and how we should handle data and why it might be useful for us. And behind those promises lies a lot of work and a lot of theories, and I will be explaining which parts of that theory or of those ideas we'll be studying. I will give you then just a very simple answer to this question. Will you have to program for the course? The answer will be yes. I will give you some advice. And then just a first assignment which is optional this time and which you can choose to do or not. But it's going to be a very short assignment. So let me just give you a few illustrations of why machine learning is now so important in computer science and why it is a booming field, both in academics and in the industry. Well, if you just think about it, maybe in a few years, thanks to data, I mean, that's at least the promise that we have, we will be able to know whether people have to go to the hospital before they actually have a disease. And so this sounds a bit science fiction, or a bit like, I mean, like a nightmare if you want, but it's something that is increasingly possible, and it was the subject of a prize called the Heritage Health Prize, which incidentally it's difficult to see with this low resolution, but this was a competition that was just over 6 days ago. And so the goal of the prize is to develop a predictive algorithm that can identify patients who will be admitted to the hospital within the next year using historical claims data. Meaning, if we have your records of who you went to see and what doctor's visit you had, is it likely that you will go to the hospital, and how long will you go there? That was the aim of this competition, and that was what I think more than 1,600 teams across the world tried to do. So from the very latest news that I hear, this was not a complete success because the task seemed to be quite hard. They had to predict very well how long a patient would spend in the hospital, and that was a bit too difficult. But still, it's one of the promises. Another promise, and this is a very, very recent data set which you can consult online. So maybe Yelp is not so famous here in Japan because they don't have a Japanese branch, but equivalents might be something like Tabelog or I think gourmet.livedoor maybe. There's a few websites where people can just rank and give grades to restaurants. So Yelp does the same thing, not only with restaurants, but it's also with the hairdresser or with. So I went to California 2 weeks ago. I had to find I needed a haircut, and so I checked on Yelp whether there would be nice hair salons close to the place where I was staying at, and I found a nice person that gave me a nice haircut. So that's for you to judge. But so basically, this Yelp website centralizes a lot of opinions on restaurants, and Yelp has recently released data for a city, I think in Arizona, yes, Phoenix, in the metropolitan area of Phoenix, and so there's over 12,000 businesses, probably a few thousand check-in. So basically, they can check whether people have been going to the shops or not, and relate this to the reviews. So that's another interesting data set. Another very interesting type of data now is arising from so-called social lending websites. So you may have heard about Akushu in Japan. There's a few other brands and websites that exist in the United States or in Europe, and probably one of the biggest is Lending Club. So it's very easy. How does Lending Club work? It's just a website which centralizes people that have money they want to loan and people that need loans. So for instance, the people that might want to loan money, I don't know, might be people who want to loan money to organize their wedding ceremony or to buy a swimming pool or more importantly to finance their studies, etc. People that have money to loan might be just people that have a few $1,000s on their bank account and would like to have a more productive way of, having interest on that. So this business was basically managed by banks up to now, but now it's managed by websites. It's increasingly managed by websites such as those here. And if you look at the total loans which have been provided by Lending Club so far, that's above $1.5 billion. So this is not a fad. It's really a big financial actor now. And what's really nice about this is that the data is almost freely available. Not all of it, but a big chunk of it is freely available. So if you just go to the web page of Lending Club, you can download loan data. So what is exactly loan data? Well, it's a CSV file, a big CSV file with a lot of information of who wants to loan money, and then you will have updates telling you whether the person has reimbursed the loan or not. So if you want to do a bit of data mining of that data set, you can predict whether people will pay back their loans or not based on that information. So another famous example of how data sets can change our daily life was provided about 3 years ago by something called the Netflix Prize. I'm not sure all of you are familiar with Netflix, but right now Tsutaya is doing a very similar service in Japan where you can basically loan DVDs and they're sent to you by mail and you send them back by mail once you've seen them. And in the process, usually, Tsutaya or Netflix asks you to grade the movie. So if you've seen the movie, if you liked it, you will put 4 stars or 5 stars. If you didn't, then we will put 1 star. And what does Netflix or Tsutaya do with that information? Well, they recommend you new movies that you can look. And so there is a big problem there, machine learning problem, which is given ratings for some movies by a user, how can we predict which movies this user will like? So in a matrix form, if you want, we have a very big matrix. So let's say we take a sample of 480,000 users and a sample of 18,000 movies. Most of that matrix is empty because, of course, most users haven't seen all of the movies. So maybe a user has seen 10 movies, 15 movies, 20 movies. But then when the user sees that movie, he fills in some information there. He puts a score between 1 and 5. So the problem now would be to predict those crosses here. Is that person likely to enjoy that movie? Okay. So what have all these problems in common, which would have been impossible, I think, 10 years ago? Well, the thing is, all the problems that I've mentioned here, for all these problems, the data is available. You can download it for free. It's there, and you can play with that data. So now, downloading it is probably the easiest part. 10 years ago, it was probably the hardest part. Collecting data was really, really costly. And you could only do the kind of research that I've been describing here if you were working in a very good performing company that had a very nice data structure. Now it's just there for free. So we have to analyze it. Okay, so that's one of the big goals in the 21st century, and that's definitely the big goal of machine learning. So in the 7 lectures that I will give, of course, we will not be able to cover even 10% of the most important techniques in machine learning. But so there are other courses that will cover part of that. So I encourage you to check other courses which mention these problems, because I think they will be very important in your future professional careers. However, in the next 7 lectures, we will focus on 3 things. So we will first present elementary tools, because if you are not familiar already with regression or classification, then it's very difficult to do anything. We really need to have a very strong basis where you understand regression and classification. And then I will study something which I think is not taught in other courses, which is the mathematical foundations of statistical learning theory. So this will imply some more advanced mathematical tools, and I will discuss them. But basically, we will try to raise issues such as what kind of model can you use or can you define to handle tasks such as the movie task. And then how can we address the problem of overfitting? So if you've heard about overfitting, you probably know what I mean. If you haven't, we will define it. And then in the last 1 or 2 lectures, I will talk a bit more about advanced methods, such as kernel methods, or talk also about sparsity. So what kind of mathematical tools will we use? So we will adopt really a mathematical formalism based on probability statistics, linear algebra, and just a bit, a hint of optimization. But I think it will be, most of the optimization ideas that we'll provide will be self-contained in the course, so you shouldn't worry too much. But we will use just very basic concepts of probabilities, expectation, variance, inequalities, maybe some convergence, some bounds, especially in the statistical learning part. Linear algebra will be everywhere, so just, well, I think you're all pretty knowledgeable in that. And then optimization. So about programming, as I was saying in the introduction, I will expect you to program, especially for the assignments. I think that's the only really valid way to understand how a machine learning algorithm works, is by actually implementing it. So there will be very few questions, very few exercises on which will require you to write an answer. Most of the problems will be about programming an algorithm. And for that, I encourage you to use MATLAB, because I think it's probably the shortest way to implement a machine learning algorithm. Of course, you can also use R or Python, which are equally short. So MATLAB, R, and Python are very good candidates if you want to implement things. I would not recommend using C or C++ or other compiled languages for 2 reasons. First, it usually takes a bit longer. But if you are even if you're a very good C++ programmer, then usually you don't have as many libraries or pieces of code which are available in MATLAB or Python for machine learning. So researchers in the machine learning area are not usually very good programmers. We're just barely, okay programmers. So usually we stop at Python or R or MATLAB. So now let me just, for starters, just some food for thought. Very few ideas in the first assignment. So this slide is on my website, so please don't feel that you have to write anything down. Just check my website and you will see all of this. So let's consider a function. So we will go back to very basics of function approximation in mathematics. So this is a function which is this polynomial, x minus 1, 4th, etc., etc. And I just plotted it here between 0 and 4. So of course, if you give anyone this formula, then the person can very easily plot this function. This is like the best summary of the function. Of course, you can see this function as a very detailed scatter plot with a lot of points. So it's a lot more time consuming to put those points here than having the formula, but sometimes this might be a way of looking at the function. And if I give you less and less points, one very simple question is, am I able to reconstruct this blue line using just a few observations? So this is one of the basic ideas behind statistical machine learning, which is usually we only see observations in nature. We only see people grading movies. We only see people going to the doctor, etc. But we never see the full function, the full blue curve. So what we would like to do is reconstruct this blue curve, which will help us decide things using just a few observations. So in this very, very simple setting, it's actually very easy. Because we know that the function is a polynomial. Even if I give you actually only the red points, there is something called polynomial interpolation, which allows you to reconstruct a few candidates for the curve. And in particular, it allows you to reconstruct this yellow curve here, which fits perfectly those red points. Okay? So if you have the knowledge that the polynomial is a 4th degree polynomial, and you have a few red points, in most cases you will be able to reconstruct perfectly the curve. If someone told you, though, that the curve was a cubic polynomial, you will not be able to reconstruct it perfectly, but you will be quite close. Okay? So you can see some of the problems that arise if you just send someone a few points and some partial information. So even if the points, in the previous case, I just put points evenly spaced, but you could imagine that the points are not evenly spaced and you could still reconstruct everything perfectly. Sometimes in real life, however, we have access to not exactly the measurements of the function, but we have access to noisy measurements. So imagine that instead of giving you the location of the red points, someone actually gave you the location of those blue points. And you still have to reconstruct this blue function. So if you run again the same algorithms, well, you will see that it's quite different from what you had originally, right? So if you start adding up the fact that you only have partial information, because you only observe a few points, that there might be some noise, then using directly this fourth degree polynomial, even if you assume people gave you the correct information, will not necessarily be the best strategy there. Okay? So I just would like you to think a bit about this in this very simple setting where the function is just unidimensional. It's just one function of x between 0 and 4. And think about those questions. So to be more precise, here is the assignment, which you will be able to see in the slide on my webpage. And please send it to me by next Monday before midnight by email. Please put in your title, in the email title, assignment. Just write assignment somewhere in the title, and that'll be fine. So those are just the very basic questions. Look for definition of interpolation. You can check the Wikipedia page. That's enough. And do what I just did with MATLAB using any function of your choice. And send me an email with the results. Choose a so I'm sorry, I just put MATLAB here, but it can be, of course, any data processing language that you want. R, in particular, will do this very well. So you can choose a function. You can use even fancier functions, which are not polynomials. Actually, it's probably more fun. Plot it, scatter, plot a few points, and try to use the curve fitting tool. Interpolate and compare. And now think about what would happen if the function that I'm giving you is not just a function of x, but would be a function of a higher dimensional, a multivariate function of more variables. So what might go wrong with this strategy in higher dimensions? So that's pretty much it for my first half of the course. So I will meet you again next Monday, and then now Yamamoto Sensei will talk about his half.
Okay, thank you.
Sorry, I have to give you
this course. Okay. Sorry. Okay, I'll introduce my part, the latter half of this course. And my course is concerning on the computational learning. And computational learning is, original meaning of the computational learning is modeling learning in the same way as modeling computation. And if you are from the Department of Computer Science, maybe you have already learned about what is a computation. However, it is somewhat very philosophical consideration. So, in my part, I will explain computational learning on the viewpoint of practical applications. And the application is learning or knowledge discovery from discrete data. And what is discrete data? It is strings, I will explain later, and like text, DNA sequence, and so on. And trees, like parsing trees on XML documents, or tables, so-called relational data, or graphs, and so on. And I will explain mainly on strings. And so my subtitle is computational learning from string data. Okay. To introduce, to explain what is learning from string data, I'll explain the learning from very simple learning mechanism from numerical data or continuous data. Okay, consider the n dimension of space of real numbers, and assumes that given two finite sets of data, C and D, each element of C is called positive data, and each element of D is called negative data. And the task of the learning machine is to find the linear function which can distinguish these two sets. Okay? Just like this here. So consider that these blue points represent elements in C, and these red points represent elements in D. Okay, and in the undergraduate course, maybe you have learned about a very simple algorithm, which is based on the so-called generate and test in the terminology of artificial intelligence. This means that at first, choose some linear function, and it is not fit to the data. Then devise the linear function according to the errors. And in the finite repetition of this division, you can the learning machine finds a linear function just like this. This is a very simple learning algorithm. Then our problem is just like this. Please assume that we are treating strings or sequences of characters. Okay? And then we treat the problem of classifying two finite sets of sequences, C and D. The setting is quite the same, but only the difference is the data is not numerical vectors, but it is strings or characters. The string means that, for example, the set must are consisting of AB, AAB, or AB, AAB, blah, blah, blah. And the set D is consisting of A, B, BBB, ABBA, blah, blah, blah. Okay? Then, how to classify these two sets? We can't use a linear equation because maybe all of you are unfamiliar with mathematics of strings. Maybe Cuturi sensei assumes a linear algebra or statistics. It is a basic of mathematics undergraduate course, but very few people, students know about the mathematics of strings. Then, at first, we have to consider about the correspondence to the linear equation, linear formula. Okay? And before that, I'll explain why strings are treated in machine learning. The reason is very natural. For example, natural language sentence are strings. It are consisting of characters in alphabet. This is a very famous paper written by Alan Turing, and this is also this is an example of sequence consisting of alphabet. Okay. Also, strings are also used in so-called bioinformatics. You know that RNA or DNA can be represented with sequences. In the case of RNA, just like this, it is a sequence consisting of 4 characters, A, C, U, G. So this sequence of strings are very familiar in biology now. And more fundamentally, computers are working on strings. You know that every data in your computer are strings consisting of 0 and 1. Okay? So strings or sentences, sequences are very fundamental data structure in computer science and machine learning. So considering machine learning from strings data is very important in the course of application. Okay? Then go back to the linear separation problem. Then in the case of treating strings, what is the correspondence to the linear equation or linear function? And the key point is that this linear function, linear equation, has a parameter, which are vector W and C. And this equation in this setting works as a machine. You know, that machine means that it is a mechanism to distinguish whether or not every data X is in C or not. Okay? So this is a machine. And more precisely, these parameters works as a program. If these parameters changes, then the activity of this machine, this equation, changes according to the change of parameters. So this is why we call our learning framework is computational. It is based on the computation theory. Okay? Then, for the case of treating strings, we should adopt machines which can distinguish whether or not every string X in C or not. And if you are from computer science, maybe you know at least one type of such a machine. Yeah, this is a finite state automata. And if you are not from computer science, please please relax, because I will explain starting with what is a finite state automaton and what is a finite state machine and so on. Okay. So this is a simple machine which can distinguish as data is in some sets or not. Then we can replace the part of equation on the previous algorithm with the finite set automata M. This is a very simple analogy of the linear separation. It works very well. The difference is just this point. This is if the automata does not accept xn or something like that. This corresponds to the in equation here. Okay. So in my lecture course, in my lectures, at first, which machines can be used for learning from strings? Okay, and for computer scientists, it is very familiar with concept as a finite state automata, and also context-free grammar is a very appropriate choice of such a learning from strings. And the contextual grammar also works just like a machine. And the last one is very rare case in such a context of machine learning, but it is very useful. It is an analogy of linear function, just like a string with variables. So imagine that plus corresponds to the catenation of string character and variable. Then this is some kind of function for strings. And the mathematics on such a type of function is very useful for providing learning algorithm from string data. So I will explain maybe in July how to use these monomials in machine learning. So all these items are from the mathematics of strings. And so in my part, we will start with the mathematics of strings, with introducing such a concept for the beginners. Okay? Then next we will explain how strings are provided as data to the learning machine. And the first case is a binary classification, as I explained before. Both positive data and negative data are provided to the machine, and the machine identifies the function in the form of finite state automata, contextual grammar, or pattern, monomials. This is a very somewhat easy case. But more difficult but interesting case is positive onto data. Just provide a positive data only. The machine must characterize the data to find the regularity of the positive data. And recently, such a learning is one-class classification or something like that, or characterization. And the last one is very specific to the computational learning. And in computational learning, some learning machine allowed to give queries to the users. Normal learning machine is very passive, just accepting the training data only. However, this type of queries can be provided to the learning machine, to the user. And the learning machine expects that the user answers. It is in C or not in C. So this is a very interesting framework in computation theory, computation learning, and I will explain the last part of this, my top part. Okay. Then next we have to explain that if the current finite state automata does not fit to the data, with which alternative should be chosen for M. And this is a fundamental question for learning machine, because if for the case of, in the case of linear separation, we can easily define the error by measuring the data and the lines, linear functions. But we don't have any such a good measure between finite state automata and the data. So we have to develop a new criteria or mechanism to find the alternative candidate. And I'll explain the enumeration by Gödel numbering. And Gödel numbering from computational theory. And the refinement of machines, which is from algebra. Okay? And at last, in what sense the learning algorithm is correct? We will explain at last. The identification is the limit criterion or polynomial time identification with queries are introduced in my course. Okay? Okay, here is a reference of my course, and for Japanese beginners, this book is best choice. Not best choice, only choice. And for English-speaking people, this book is the only choice. There's no other books on this subject, on computation theory from strings. Okay, so it is very particular subject, but I explain because of the importance of the materials. Okay. Okay, this is my explanation, my part. Okay. Do you have any questions?
So maybe we should introduce Tam.
Please stand up. Tam is a teaching assistant of this course, and he will help us.
For the assignments, if you have questions, you can ask us or ask Tam. If it's a practical question, you can probably ask Tam. If it's a question on the course, please ask us.
And Tam can speak Japanese very little.
So I will put Tam's email address on my website next to the first line.